Welcome. At the board, we have an example number 1. In 24 days, a radioactive isotope decrease in mass from 64 gram to 2 gram. What is the half-life of the radioactive material? What is the half-life of the radioactive material? From part 1 of the video, this is the part 2. From part 1 of the video, we already know that half-life is equals to either small t all over log base of 2r or cap. This, it can also be t times log of 2 all over log of r. Any of these formula you use it, you can get the answer. For my candidate preparing for examination, you have to use this formula. Why? Because you don't use calculator in JAMB. Calculator that you can press log 2 or log r. So you have to understand this one. Those that are writing WAEC or are in O level or year 1 in the university, you can use this one because you are permitted to use scientific calculator. So any of these formulas will give you the answer. Now, they ask you to calculate it. This is so easy. I told you. They ask you to calculate the half-life. So this is the half-life. Now, but they have given you in 24 days the time taken in part 1 of the video. So first of all, you have that your T is equal to 24 days. A radioactive isotope decrease in mass from this, meaning that your capital N1 is equals to 64 gram, and then your capital N2 is equals to 2 gram. From this to this is the final one, it decreases. What is the half-life? So remember from part 1 of the video that your disintegration ratio is N1 all over N2, right? So this is just your N1 is 64 all over 2, and that will give you what? 32, right? Good. You just have your disintegration ratio. You already know the time taken. You can calculate your half-life. Very easy. I told you. Now, your half-life from this place is now T, the time taken, which is 24 all over log of base 2. Now, this is R, log R base 2. So this is 32. Now, you have to do a little bit of mathematical calculations here under logarithm. Now, people that are writing JAMB, this is so easy. Pay attention. Immediately you come to this place, ask yourself, 2 raised to the power of what will give me 32? It's so easy. Because if you do it, this is 24 all over log base 2. 2 raised to the power of 5 will give you 32. 2 raised to the power of 5 should give you 32. Now, the next thing we are going to do is cancel out. Under logarithm, those that knows the topic very well, if you have log of 2 to log 2 base 2 is equal to 1. If you have log 4 base 4 is equals to 1. If you have, once you have log 5 base 5, once the log and base are the same, your answer is what? 1. So come back to this place. You have log 2 base 2, so this is 1, right? So you have 24 into 1 times 5. So this will give you your half-life T is equals to 24 all over 5. And that should give you an answer of 4.8. So 4.8 days. Be careful now. The time is in days. So your half-life should also be in what? In days. This is so easy. I told you. And of course, this is my formula. If you do not watch the part 1 of my video, you will not understand anything I'm saying right now. So endeavor to watch the part 1 of the video. Let's go to another example, please. Now we are into another example. The half-life of a radioactive material is 6 hours. What quantity of 1 kg of the material will decay in 24 hours? From the solution, they said what quantity of 1 kg of the material will decay meaning that they want you to calculate the number decayed, which is the ND. Remember, ND have three formulas. It's either you're using this first one, N1 into bracket R minus 1 all over R, or N2 into R minus 1, or you are using this any of these formulas. Now, in the question, you are being given the half-life is, which is a capital T, is 6 hours, right? What quantity? So they gave you N1, which is 1 kg, right? With decay, and then you have your T to be 24 hours. Now, can you see that you cannot use this second one or third one? Why? Because they are not giving N2, right? So we can use this one. We were not giving disintegrating ratio, but we can calculate the disintegrating ratio. Remember, the formula for disintegration ratio is 2 raised to the power of n. Another formula is n1 all over n2. So any of these formulas can solve the disintegrating ratio. Remember again, we cannot use this formula to get disintegrating ratio. Why? Because we're not giving n2. So this is the only formula I can use, right? Now you have 2, but are you giving n? No. But you can get n, right? Yes. So n, which is the number of half-life, n is equals to small t all over capital T, right? So your small t is, so your n is equals to, your small t is 24. Your capital T is 6, right? So that should give you 4, right? So your n is 4. So if your n is 4, you can get your disintegrating ratio. And so this is R is now 2 raised to the power of your n, which is what? 4. Right? Good. Now, if 2 raised to the power of 4 should give you what? 16. That's all. So since you have calculated your disintegrating ratio, you can now put it into this formula and get your answer naturally. So ND, which is equals to N1 into R minus 1 all over R. And your N1 is 1 kg, right? So into bracket, your R is 16 minus 1 all over 16. So your ND is now equals to 1 kg into bracket 15 all over 16. And this will give you, this time this will give you 15 kg all over 16. So that should be the answer. 15 kg all over 16. Or sometimes you can also put it like this, 15 all over 16 kg. So if you're already familiar with what we are doing, the formulas have been given from part 1 of the video. The part 2 of the video will be a child's play for you. Remember, if you know all these formulas, all you need to do is which of those can go in any of these formula, and your answer will be flowing naturally. So the more I solve examples, the more you will learn.